We're almost there. We have now talked about the platform, we've talked about the web server, we've talked about persistence. Now we get to talk about AngularJS, the user interface. And even though there are lots of different JavaScript libraries out there, I've worked with Backbone, I've worked with jQuery Mobile, there are lots of other ones that look intriguing that I haven't worked with. Ember.js and React and Knockout, all kinds of different libraries out there. There are some things that are unique about Angular, and there's some things that are shared across all those libraries. Out of any of the components in the mean stack, this piece right here, the user interface, is arguably the one that's going to be most likely to be swapped out for some other user interface library. And that's fine. That is why the stack is built the way it is. We should be able to swap these things out. But what we're going to talk about first are some general things you should be looking for from a single page app. And then once you've decided that you want to use Angular, we'll take a deeper dive into Angular and look at 4 things that make Angular a little bit different than many of the other common solutions out there. But to begin with, and in a bit of foreshadowing, you can see that when you go to angularjs.org, they say it right up front that Angular is HTML enhanced. It's not a JavaScript-centric framework. It's not a CSS-centric framework. It is unapologetically HTML-focused. We'll talk about what that means. But I said at the beginning of this, as we're rearranging our mean stack to our NEMA stack to get us a better set of analogs here, we can see that Node is an analog for Linux, but slightly different in that it's a platform, not an OS. We said that Express is standing in as an analog for Apache, but it's a little bit different in that you embed Express in your app instead of deploying your app to an external web server. We talked about how MongoDB gives you just as much persistence as MySQL does, but in a slightly different way. You're moving from a relational database to a NoSQL database, and specifically a document database, and that brings a new set of capabilities and a new set of weaknesses as well. But Angular, this is where I said that this is the sound of our analogy kind of stretching almost to the breaking point. I'm not trying to suggest to you that Angular, a framework, is a strict equivalent of Perl, a programming language, and a general purpose programming language at that. But both of these are serving the same role, presenting the UI. But when I said earlier that HTML enhanced is what I like about Angular, we find that most solutions out there, Perl being one example but not the only one, is a programming language that emits HTML as an afterthought rather than being HTML focused to begin with. So we'll spend a lot of time teasing out the differences between using a more general purpose language versus something that is purpose built as a web framework. So, you've seen this visual model before, this mental model. You've seen the LAMP stack before. You've seen the mean stack. Now that we're talking about Angular, we can focus on that browser down in the corner there, because this is what's missing by design out of the LAMP stack. When the LAMP stack rose to prominence, we thought that browsers were these cute little underpowered things that you could pat condescendingly on the head and say, oh, don't you worry about working too hard. We'll do all the heavy lifting on the server side and then just send you the results. What we've discovered now is that I'm carrying a quad-core processor in my pocket these days. This smartphone has more computing power than my first 3 computers put together. So we can truly distribute our application. We can truly offload many of the things that we historically have done server-side and handle them client-side. So this is the biggest distinction between moving from a general-purpose server-side language to a purpose-built client-side web framework. And really, another way to discuss this is just saying, hey, we're dealing with single-page apps now. SPAs. So what I want to talk about first are, what does it mean? What are the ramifications of moving to a single page application or single page architecture? And then we will turn around and discuss how Angular is a really nice option if you decide to, in fact, build a single page app. So, a single page application has 4 key characteristics we're going to look at. A single page app is, well, yeah, it's single page. All right, that one's obvious, but we'll talk a little bit more about it. But more importantly, a single page app is client side, it's component oriented, and it is deeply asynchronous and event driven. So let's talk about single page apps. Historically, whether you're using the LAMP stack or not, you were probably building a multi-page server-side app. And what that means is, well, you have multiple pages. Exactly. You have an index.html page, you have a grid page, you have a details page. And the fact that these are multi-page apps means that every new click in your application is generating a full HTTP GET request response cycle. It's doing a very coarse-grained replace the entire set of information on my page with this entirely new set of information. How does that contrast with a single page app? Well, again, we said a single page app is a single page app. And what that means then is you load the page once, and rather than doing coarse-grained request response cycles, what you end up with are divs that you programmatically show and hide throughout your application. This is so significantly different. I really like thinking of this not in terms of page transitions, but more in terms of state transitions. All right, I'm in a login state right now, and now that I've logged in, I am in a home page state, or I am in a household state, or a unit state, or a waiting list state. I am absolutely moving from one context to the next, rather than one page to the next, So the browser, as we've said over and over again, really doesn't play a strong role in a traditional server-side, multi-page MVC application. But here's what this ends up looking like. When I go to do something in my application, let's say I'm writing my own search engine, because I can't think of any good ones out there. So I've written my own search engine, and so that HTTP request that I send up to the server has a query string inside of it. Query string, like, show me all the articles in JavaScript. So what happens when that request comes up to the server? We have a router that is catching that request. And that router, as the name implies, is deciding where it should send that request. It's choosing one of many controllers, and once it hands it off to the appropriate controller, there's probably a function call inside of that, and that function can reach out to a database. It can materialize that data out of the database as a model or an array of models. It can hand that array of models to the view, the templating engine, and then from there we assemble the search results. We assemble that full HTML page, and that full HTML page is what we put back on the wire as the HTTP response. There's really nothing revolutionary going on here, and there should be nothing surprising. This is how we've been doing web development since the beginning of time, or at least since the late 20th century. So the mean stack changes this in that we're not only moving from a server side to a client side, but the role of the client is greatly increased. So in that same example before, when we're dealing with clients and servers and we're dealing with these search results, one of the first things you'll see is you'll notice we're not going to /search, we're going to #search. And anytime you see this hash, or this pound, or as it's officially called in Latin, this octothorpe. Octothorpe, of course, is Latin for 8 thorps, right? Yeah. No, 8 points or 8 sides, but yeah, an octothorpe right there, whenever you see that, that is now all of a sudden an URL fragment, and you should know that's not generating an HTTP request response. It's looking for a named anchor within the page. Any Wikipedia page you visit, when it has a table of contents, click on those elements in the table of contents, and you'll see that as you're clicking on those table of contents entries, it's not generating a new request, it is scrolling you to that portion of the page that has that named anchor associated with it. So a single page app is simply taking advantage of this and saying, well, anything with an octothorpe in front of it is going to be kept local. So if that request is kept local, well, then we're going to need a local router. And that local router is going to be the one that determines which one of the local controllers it gets handed off to. Here's where it gets interesting, because that controller might have everything it needs to satisfy the request. Notice we haven't talked to the server yet, and if the data we need is cached up or simply available to us locally, we don't ever have to talk to the server. But in the case of search results, chances are very good that we don't have every JavaScript document, every JavaScript article ever written cached up locally. So we probably will need a round trip to the server. But what we ask the server for and what we get in response is not a fully rendered HTML page. In fact, it's the pure model data. It's the raw JSON coming back. Once we get the pure JSON back from the server, then all of a sudden on the client side, we can materialize a model or an array of models. We can pass it through the views, template it up, and what we end up with is not a full HTML page, but that div, that fragment. And that fragment is then shown or hidden or displayed appropriately. So you can see in this model right here, there are a number of benefits. First of all, almost everything happens client-side, which does nothing but increase performance and responsiveness. There is no faster way to present a UI to someone than one that's already locally resident and in memory. When we get this data down, we can decide to cache that as well. So even though the first request for JavaScript articles had to round trip to the server, it doesn't mean that every subsequent request can. We can cache those things up locally in local storage or session storage or Web SQL or any of the local browser-based persistent solutions we have. And what this means as well is that your data will have different life cycles in the pages itself. When I was working for a large cable company, we found that people subscribed to premium channels very infrequently. If you already subscribe to HBO, you probably have for years. If you subscribe to Showtime, maybe you just added this year, but you're going to hold on to it for several years. So when we were building our HTML5 app running on a Samsung TV, we found that we could ask for what our premium channels were once and then cache that up in local storage. We might periodically send out an asynchronous request, but we would treat local storage as our canonical truth and only update it when we get the need to. Something though like what's playing right now on TV, that data has a very different temporal life cycle. Something like that we might round trip to our cable set-top box, which was a RESTful set of endpoints. That cable set-top box, we might get that data, we might cache it up, or we might not. But by divorcing the data lifecycle from the UI UX lifecycle, it gives us a lot more fine-grained control over what we cache and what we don't. We've now figured out what a multi-page client, a server-side MVC framework looks like. We've found what a client-side MVC framework looks like. Another big difference between the two are whether you take a more page-centric view or a more component-oriented view. So if you were to look at this wireframe right now, Backtube, this mashup of Backbone and YouTube, you can see when it comes to the mean stack, we could use any client-side library that we like. But when you look at this page, if you look at it from a page-centric view, This might be the pseudocode you use to build up a page. You might say, all right, I want to turn around and build up that left side first, get all the menu categories, get my hands on a sidebar, walk through each one of those elements in the sidebar, build up an unordered list with list items and write it out. And then the main portion of the page as well, I'd want to do something similar. Build up the div, get the box art or the cover art that we need. And since we're doing this all server-side, we do assemble it all server-side and hand the results back down to the client. Well, that's a page-centric approach because we're thinking in terms of whole pages that are going to be sent back down the wire. But what if we had something that looked like this, identical to the end user, but they were a couple of components? Not a whole page, but a couple of loosely coupled, highly cohesive components. Components that we can new up. I'll new up a sidebar, I'll new up a new list, but I don't have any idea what's going on with the implementation. That's actually a good thing. This is encapsulation, isn't it? But what if you have two components that need to talk to each other on the page? What if I click on comedy on the sidebar and I want to see comedy movies in the main page? What if I click on sci-fi on the sidebar and I want to see sci-fi movies in the main page? Well, we end up setting up event listeners. Now, this is very simple and naive. It's pseudocode after all. But we can do a point-to-point listener. We can say, all right, main page, you be listening to the events that the sidebar sends out. So as I click on a different category, this main page can receive the message, react to it, either round trip to the server if it needs those files, or pull it out of a local cache. But the clicks on the left side of the page are event-driven, and that's how the main page updates. This component orientation can be very powerful. And you can see it's hard to talk about components without talking about an asynchronous or an event-driven nature of dealing with those various components. But I told you earlier that I've been dipped in synchronous programming almost my entire career. So I still think of my code this way. I still think of it as a Pachinko machine where I drop a stone in top and I watch it work its way through the function and come out at the bottom. So if I'm taking a server-side, page-centric, synchronous approach to this, it means I'm first going to reach out to the database and get all my sidebar items, and then I'm going to build them out, and then I'm going to reach into my database and get all the movies that fit that category, and then I'm going to build it out. But these are synchronous calls. I know that line 2 won't happen until line 1 is complete, and line 3 won't happen until line 2 is done, and so on and so forth. We've learned that JavaScript is not just a little bit asynchronous, it's asynchronous all the way down. So you can imagine this model is not going to fly if JavaScript is your core language. So I've moved from pseudocode to more realistic code. This is AngularJS code. But we can see that I've got this event listener right now called View Movies of Type. And so the idea here is as I click on items on the sidebar, this guy is going to turn around and query movies that match that particular type. And since this is asynchronous, I can bring in the promise library. Remember, promises are part of the common JS specification. But jQuery offers one implementation. In this case, Angular offers another. So if I'm going to generate an AJAX request, that's the movie's query call right there. The promise says, I promise the then won't happen until the query is done, until the AJAX response comes back. Then, once I have the AJAX response, I will build up an arbitrary JSON block named data. And you can see what I'll do. I will emit a change main view event and attach the data with it. And then it's up to anyone who is subscribed to this. Not a simple point-to-point, but if I push this out on a message bus, if you will, and anyone else who is subscribed to that message bus, and specifically that message, will be able to pull the data off of the wire and do what they need to do with it. So when it comes to implementing the main view, all it has to do is say, hey, guess what? On this particular event, grab the data and then do what you need to do with it. So this event driven nature of JavaScript is not going away. Promises do a nice job of making it appear synchronous, and sometimes you truly do want to say, I want to grab dataset A and dataset B and dataset C, and only when I have all three can I do something. You can do that with then constructs, you can do that with fork join constructs, but the promises library allows you to add synchronous-like behavior to the native asynchronous nature of JavaScript. But regardless, we are going to be event-driven all the way down. So when I look at Angular, absolutely, it is HTML enhanced for web apps. It's a really nice framework on top of that. But the way I would describe it to one of my clients is I would say, okay, Angular is a single-page app, which means that we're dealing with client-side MVC, not server-side MVC, which means that we're going to take a fundamentally component-oriented approach to constructing our pages. And these components are going to communicate with each other in a very asynchronous, event-driven manner. I mean, when you say it like that, it makes perfect sense, doesn't it?